Pretty tough final problem for the 2018 SAC here. So let's have a look at it. Consider the shaded area on the graph below. So that's this stuff here. A horizontal line with the equation y equals p is drawn through the graph as shown below. Find the value of p ramped to 3 decimal places such that the shaded area is divided into 2 parts. Okay, so in a previous part of the question you would have found that f of x, this top function here, is this, and g of x, this bottom function, is this. Now the way we're going to do this is this line y equals p will be at exactly the same point if I only worry about finding the area of half the graph. So imagine this split like this, and we'll just concentrate only on doing this part here. We don't really need to worry about what happens on this side. Okay, so what we'll do is instead find half of this shape and pop the line there. So the line for half of this will be the same as the full shape. So the first thing we'll do is actually find this area here. So this area here is going to be found by integrating between 4 and 0. And top function is f of x. Take away bottom function is g of x dx. Alright, so let's go to the calc now and define those. I'm going to pause this video to define them and then I'll unpause. Okay, so they're both defined now. So now what I'm going to do is do my integral between 4 and 0. Top function, take away bottom function. That's the exact value. Let's get a decimal. Okay, so this area here is 14.014 ... units. All right, so what I want to know is how much area is contained in half of this. All right, so half the area is, so I'm going to divide this by 2, 7.00702 ... units squared. Okay, now the hard part. Okay, so what I need to do is to work out, so I'm going to start finding the area under the curve between this curve here, so this one, and this line here. So I'm going to continue to move along here, along this line here now. It might be here, so this point here and this point here might be that area, but I'm going to continue to move along to a certain point over along the x-axis here until I get an area of this. Okay, so let's just see if we can handle this. So I want the area to be 7.00702 ... equals. Now I'm going to integrate between 4 and a value over here. Now what's the value going to be? Well, the y value here is p. What's the x value going to be? We're going to get the x value by working out what the intersection is between this line, y equals p, and this line here, which is f of x. So what I'm going to do is solve f of x equals. Now one thing to note is that you can't use the variable p on the calculator. I've forgotten why, but you're not allowed to use it. Okay, so we're just going to call this z on the calculator. So when does it equal z? And I'm going to solve that for x, i.e. I'm going to get the x value out of it. Okay, and the x value is this thing here. Now I'll just go and write this as that. All right, so it's going to be between 4 and an x value that is this particular value here. Okay, so this is the value of x, and it's written in terms of z, whatever this line is here. So I'm going to write that out. It's a pretty ugly number. Negative 4 ln negative p on 16 plus 1 over ln2. You can write it as log e if you want. All right, now, so they're the terminals between 4 and a value that I don't quite know yet, so somewhere along this x-axis here, okay, and where it's going to be will relate to this p-value here, whatever the p-value is. All right, now what I'm going to do then is the area then is going to be, the top function is f of x, and our bottom function is this line here, the line y equals p. So our bottom function is take away p dx. Right, so what we're basically doing is integrating between there and a value I don't quite know yet, top function, take away bottom function, dx, and I know what the area is. So this is known, okay? So what I'm basically going to do is solve this thing for the variable p. So we'll go to the calculator, and what I'm going to do is run a solve, so a shift and equals, and we're going to pop all of this value here, or the exact form of it, equals integral for this thing here, top function, bottom function in our case is z, dx. I think that's all we need. And then I've got to hit the right arrow again, so this right arrow here to get the big kind of flashing line, because I need to tell it what variable to solve for, which in this case is solve for z, please. All right, here goes. Fine. So I've got two possible solutions, 3.2, okay, so z is 3.2, or z is 11. Now let's have a look at the diagram. So z, remember, is p, so we've used p. So it can't be 11, so the only possible answer is the 3.2. So there it is there. So we're going to say that p is equal to 3.20387 ... or I think it's 3 decimal places, therefore p equals 3.204. All right, so there it is there. See how you go with understanding that, and yeah, ask some questions.